So today we will be looking at the binomial theorem, which follows on from binomial expansion, and it's a bit of a shortcut way in which we can do binomial expansion. So here it is in all its glory, the binomial theorem. Now, the binomial theorem is a way to work out the expansion of a binomial. So remember, x plus y is they're two and they're numbers, so binomial, and the expansion relates to this power here. So if we have some x plus y to the power of n, the way we work it out is we start with using our combinations that we learned before. So n choose 0. So we call this the first term, and hence the next one is the second term, and so on. All right. So in the first term, we start with n, the power on the top, and 0. All right. So we pronounce that n choose 0. Then we put that in our calculator as a combination, and that will give us the number that goes in front of these powers. We then start with our first term, x, and put that to the power of n, which is part of our equation, x to the power of n, and then we start with y to the power of 0. Now, that might be a bit random, but the next one, it follows on. So we started with n choose 0. The next one we say n choose 1, okay? So n choose 1, that will give us the value of our second number. We minus 1 off our x value, and we add 1 to the y. Okay, so this is exactly what we're doing in binomial expansion, and we go on again n2. Now, the reason we have these combinations there is because we remember this thing, Pascal's triangle. Okay, and as it goes down, it continues to get bigger. But what we can say is another way of writing this Pascal's triangle is by using these combinations. So the first one we have each number will start by the row on the top, so 1, and at the bottom they'll always start with 0. So 1 0, and the next one is 1 1. So this is equivalent. This term is equivalent to this, and this term is equivalent to this one. Okay, so the second level of our Pascal's triangle can be represented with, we've got row 1, so the next one can be represented with a 2 on the top, so that's for row 2, and the first term, or the 0th term, is 2 0. The middle one's going to be 2 1, and then 2 2. Okay, now we've got to remember that although we call this the first term of our binomial theorem, we always use the 0 to get that number out in front. So again, it will keep going down like this: 3 0, 3 1, 3 2, 3 choose 3. Okay, so what that means is this 3 choose 1 and this 3 choose 2 are equal to these middle values here. So if you put that in your calculator, you'll get 3 for those. All right, so this is just a shortcut way of not referring to our Pascal's triangle every time to represent the binomial theorem. So let's have a crack at an example now. So x plus 2 to the power of 5. What I'm going to start with is I just realize that my n here is equal to 5, and I just want to follow the pattern across just as shown here. So the first thing I'm going to start with is my n is 5, so 5 choose 0, x to the power of 5, and 2 to the power of 0. So you can see I've just matched this directly downwards, and that's all I've really done at this stage. So you can see there, instead of putting n choose 0, I've put 5, because our n's 5. X has become to the power of 5, again our n's 5, and our y has become a 2, so I've just put that in. Alright, so if we follow that across, my next one will be, I have to have 1 at the bottom, that's non-negotiable, and my top's still 5, so 5 choose 1, and x is going to be the power of n take 1, so 5 minus 1 is 4, and I might write that 5 minus 1 in there for now, and then y to the power of 1. And as we keep going across, it's going to be 5 choose 2, x to the power of 5 minus 2, y squared. Okay, and we keep going across like that. I'm not going to show you every value, but we'll just skip ahead now. So I've just expanded that out there, and you can have a look at that, and it should all make sense. So what we can do now is we can simplify that. So if you put this into your calculator, all right, so remember that this form, so n choose r, can be put in your calculator as n c r, that function in your calculator. There's also a formula. If you do not remember these, you need to go back to the combinations video and have a look at that. But let's move on. So 5 choose 0. If you put that into your calculator, you'll get 1. So these things are always going to be 1 and 1 on either end, but never mind about that. So x1, x to the power of 5, that doesn't change. And 2 to the power of 0, that equals 1. Okay? Plus 5, 1 equals 5. X to the power of 5 minus 1 becomes x to the power of 4. 2 to the power of 1 becomes 2. Okay, and we keep moving on like that. So 5, 2 is 10. X to the power of 3 times by 4. Plus, again, that will be 10. X to the power of 2 times by 8 plus 5. X to the power of 1 times 16 plus 1. X to the power of 0, and that will be 32. All right, so what we can do now again is simplify a little bit further. So 1 times by x to the power of 5 is x to the power of 5 times another 1 is just x to the power of 5. So we can simplify this to x to the power of 5 plus we can multiply like terms. So the 5 and the 2 are both numerals, so we can multiply those together. So we're left with 10 x to the power of 4, and that will go on. So 10 times by 4 is 40 x to the power of 3 plus 80 x to the power of 2 plus, again, we've got 80x plus 32. Okay, so that is our final solution using the binomial expansion, or the binomial theorem. And it's a little bit easier than going to our triangle every time and using that. Now there's also a little bit of a formula for working out each term. So like I mentioned, this is term 1, 2, 3, and so on as we go down, and we finish with term n, depending on what value we've chosen for n. And this is the general term. So what we do is we have this tr plus 1. This t stands for the term. T stands for the term. What we have here is your n choose r. So if you're interested in term number 1, you need to make this equation equal 1. All right. So r plus what? R plus 1 equals 1. So therefore our r has to be 0. It only makes sense that way. Okay. That r you choose here goes into this equation. And then we just use our binomial pattern here. So we'll have a look at an example of this. I think it will be a little bit easier to see then. So let's have a look at this example now. We want to find the 7th term of this binomial here. It's to the power of 14. So we don't want to find all of them because it will take a little while, but we just want to find the 7th term. So the way we do that is we say, if I want to make 7 out of r plus 1, I have to let r equal 6 plus 1. So 6 plus 1 is 7, so that will find me term number 7, which equals my n here is 14, and my r, we just set that as 6. Okay, then I put my a value. So this is my a value here. 3x. I put that to the power of n minus r. So 3x. And whenever you're doing this, you should put brackets around it because it makes it a lot easier to work it out. So n minus r, so that's 14 minus 6. And then my b is multiplied by negative. That negative comes along. 4 over x squared to the power of r, which is 6. Okay, it says, my answer says do not simplify, but I'm going to simplify just slightly. So term number 7 equals 14, choose 6. So you just chuck that in your calculator, you get a value. 3x to the power of 8 minus 4 on x squared to the power of 6. Okay, so I'm not going to simplify any further than that, but that's how we could find term 7 of our 14 a binomial to the power of 14. Okay. Thank you for watching. Hopefully we can move on from here.